A future airliner engine may look as if somebody forgot to install the cover. That missing cover is the point. An open fan engine moves a much larger mass of air without surrounding the fan blades with a conventional nacelle.
Jet propulsion is a trade between how much air the engine moves and how much it accelerates that air.
For the same useful thrust, pushing a larger mass of air by a smaller speed change can be more efficient than pushing a smaller mass much faster. Modern turbofans already moved in this direction by growing their front fans. An open fan goes further by removing the duct that limits fan diameter and adds weight and drag. The geometry is not simply a giant propeller. NASA's recent open rotor design work describes a rotor followed by a stator.
The rotor adds energy and swirl to the airflow. The stationary blades behind it recover part of that swirl and redirect the flow into useful rearward momentum.
In NASA's reported design study, the stator produced a meaningful share of total thrust rather than acting as decoration. Removing the nacelle also removes something useful. A duct helps contain noise, protect the fan, and control airflow around the blades.
Exposed tips create difficult acoustic patterns. Engineers have to manage blade loading, rotor speed, spacing, wake interaction, vibration, and what happens if a blade is damaged. The aircraft's structure and passenger cabin have to live beside that system for thousands of cycles.
That is why NASA's 2026 research solicitation focused on a flight demonstration plan and risk reduction. A ground rig or computer model can measure efficiency and noise in controlled conditions.
A flight program has to show how the propulsion system behaves across takeoff, climb, cruise, descents, crosswinds, icing conditions, and repeated operation on an actual aircraft. Installation changes the answer too. The fan's wake can interact with the wing or fuselage.
The engine needs clearance from the cabin and ground. Maintenance crews need safe access. Certification teams need evidence for blade containment or equivalent safety strategies when there is no conventional case around the rotor.
The interesting claim is not that exposed blades are new. Propellers have existed since the beginning of powered flight. The new challenge is combining very high bypass-like efficiency with airliner speed, airliner noise limits, and airliner reliability. The next milestone is not another rendering. It is a representative propulsion system flying enough conditions to reveal whether the fuel advantage survives the airplane around it.